Hey guys, I've got Kermit torn down here. Just getting ready for Mount Washington Climb to the Clouds this week, doing a final nut and bolt check. And I figured that, well, all of the body panels are off and everything's visible, give you a look at what's going on underneath the skin here. So I've had this car for 11 years, since 2015. It was built in 2007. Had originally an R1 Yamaha engine in it, and then when I bought it, it had a Hayabusa motor. And for the last 3 years, it's been getting this conversion to fully electric. So starting here in the back, that is a Tesla small drive unit out of a Model S. That would have been the front drive unit from an all-wheel drive or a Plaid model. And then inside the box right in front of it here, that is our battery box, which is stuffed with 6 modules out of a Chrysler Pacifica hybrid minivan. And so this is a 400 volt system that this car is operating on. There's six batteries in series, giving us that 400 volts. All of our high voltage connectors come out the side here. So we have our main service disconnect, the drive unit adapter, and then 2 smaller connectors, one going down to the onboard charger, the other one going up to the steering pump that I'll get to in just a second. The drive unit itself, we're running Porsche 930 CV shafts here. So these are actually the same axles that I used to have in the car with the Hayabusa motor. They have these handy Tesla to 930 drive adapters. So that was very convenient. Tucked up underneath the box here, that is the AEM CCU. So that's our combined charging unit, gives us a level 2 6.5 kilowatt onboard charger, as well as our DC-DC to provide all of the 12 volt power in the car. I'll jump to the front here. There is a 12 volt battery on this car. It's this cute little guy right here. And it's basically just enough power so that when the car wakes up, we can close the contactors in the box, and then all of our 12 volts then comes from that DC-DC converter underneath. On the passenger side of the battery box here, we've got our coolant connections. So the batteries are liquid cooled. There's a cold plate. You can see where the connections are going in and out here. That's the upper cold plate. And then there's one underneath the box that isn't really visible, but you can sort of see there's a couple weld seams here. There's a row of batteries, 3 going across the box from side to side down here, a second row of batteries in this section, and then in the very top section above the cold plate, that's where we have all of our BMS modules, the battery management, the fuses, the contactors, relays, everything that needs to be critically controlled inside the box is there in the top section. We have our 12 volt power connector going in, and then all of our low voltage communications in that harness in there. So everything gets tucked up pretty nice and tidy. Other than the couple high voltage cables, the one going back to the drive unit, there's really not a whole lot of wiring that's visible in this thing. It is a center single seat, which is how this car was originally built in 2007. When I bought it 11 years ago, the previous owner had moved all of the steering and drive controls over to the side and added a second seat. But the chassis was never really designed for it. It was pretty tight. So I moved everything back to the center during this conversion, and now there's plenty of cushion should anything go wrong. Hopefully not. Up here, we've got a 5-gallon tank. This is actually just full of straight water. So we have straight water coolant with 2 pumps, 2 12 volt pumps. One goes to the oil to water heat exchanger on top of the drive unit. That actually cools the differential gear oil, which is what cools, the oil is what cools the windings on the electric motor. The other pump goes through the battery box and then through the inverter and the charger. These 2 quick connect fittings here, those are for an external radiator setup that we have skid mounted to bring on the trailer to races. So in between runs while we're charging, we can actually connect up our external radiator with an extra 10-gallon tank. So then we've got 15 gallons of thermal mass with a much larger radiator that we're able to get everything back down to ambient in between runs while we're charging. And then up front here, this was really the main driving factor behind doing the EV conversion. So This is a system that we've had for sale for a year. We've been working on it for several years. This is a Terzo Power Hydropulse EHSU. This one in particular is a 2.5 kilowatt unit. And what it is it's a high voltage electrohydraulic steering pump. So there's a hydraulic pump down in this section here. In the middle is a high voltage permanent magnet motor, which is variable speed. And then in the top are the onboard controls and inverter. Now, this pump unit needs to be told what to do. It all operates on CAN bus communication. And so we have a radial dynamics CAN bus control module, which is mounted up underneath the dash panel here. So we take all of these inputs from the car and we drive that pump on demand to minimize energy waste. One of the ways that we do that is with this unit here. That's a torque sensor that we produce. And so what we're doing is we're looking at steering input or steering torque to the steering wheel from the driver. That signal gets sent back to the control module, which then ramps up the steering pump motor or the flow rate to be on demand. There's also one of our billet steering columns here. This was actually the car that I designed that particular steering column for, and then went into production after I put it in here. That one in particular is a prototype, but working awesome. We've got our flagship product up here. This is a 3.5-inch Vortex reservoir. The reservoir is really the product that started radial dynamics in the first place. And then what's neat about the steering setup, so it does have a rack and pinion in here. This is a 2-inch by 4.5-inch Fortin rack, but I'm not actually connected to the pinion. This is set up with a 120cc M&S orbital valve, and this is fully hydraulic steering. So we just run from that orbital to the left and right ports on the hydraulic cylinder portion of that rack. And with the orbital valve, just by changing the displacement, swapping out a different unit, we can very quickly change the steering ratio. This one, as it is right now, ends up being about 1 turn lock to lock, so it's fairly quick, quite responsive. And even though a lot of people might be very hesitant to run full hydro steering on a high-speed application, this steering setup as it is now is quite stable. This car, I've personally had a top speed of 107 and that's miles an hour, since finishing the conversion a few months ago. And at that speed, it is very stable. Granted, that was on a track, on pavement, but just goes to show that even on a high traction surface, that full hydro can be a viable option. Now, like with any full hydro system, the steering wheel does drift over time. So if I start a run with the steering wheel centered when the tires are perfectly straight, when I finish my run a couple miles later, that steering wheel is not going to be perfectly centered anymore, but that's something that I'm willing to deal with. And really just using this car as a testing platform so we can try out a bunch of different steering configurations and equipment and prototypes and make more cool stuff. So I'm very excited, looking forward to Mount Washington. This is the highest peak on the East Coast. This race doesn't happen every year. It's been 5 years since the last time we ran it, but I will be heading up in just a matter of a few days. And if you want to follow along, Climb to the Clouds is the Mount Washington race. Should be a good one. I'm going to be trying to live stream from the car. We will see how that goes, but hope you enjoyed this walk around and hope to see you there.